So we are going to continue our study of logs. We're going to do some log solving and do some log rules today. So the first thing we have to remember, when you want to switch from a log to an exponent, or if you have an exponent problem and you want to switch it to logs, then what we do is use the log circle. The log circle is going to help us switch back and forth between the two. Okay, when you get stuck in an exponent, you switch it to a log. All right, take a look at this right here. How do I solve this, or how do I evaluate this? It helps sometimes to say the answer is equal to x. Now, if I find x, I'll have the answer. And this is a log problem, so I'm going to switch to an exponent. The base is 2 to the power of x equals 16. I think I'm going to make some common bases. 16 is 2 to the power of, come on, you know this. That's a 4. Base is equal to base, so the exponent equals the exponent. Okay. Let's do this next one over here. I'm going to also call this answer x. Now let's go for x. Let's find the answer. I've got 3 to the power of x, and that equals 1 over 27. Also going to solve this by making common bases. 27 is 3 cubed. I love that I have bases of 3's, except this one's downstairs in the denominator. Let's bring it upstairs and write it as 3 to the power of negative 3. If you have common bases, then you have equal exponents. X is equal to negative 3. And some people say, wait a minute, let's go ahead and check this answer. Okay, but when I look at my original problem, the negative wasn't going into the log. That's okay. All right, let's take a look at the next couple. If you are trying to solve for x, but it's stuck in an exponent, can I divide both sides by 2? No. Can I divide by e? No. We're stuck in exponent form. I think it's time to switch to log form. Now, what kind of log should I use if the base is e? Did I hear you say natural? You are correct. Natural log. Okay. The base is e to the power of 2x equals 5. Now, we're not going to write the base of e. That's what a natural log has, so we don't need to write that. Let's just do a quick log circle to make sure I set this up the right way. E to the power of 2x. Yep, that log circle's working. I almost have x alone. I'm trying to solve for x. If I just divide this side by 2 and this side by 2, then I'll have x. X equals natural log of 5 over 2. Now let me ask you a couple questions. Is 2 in the log? And the answer is no, it's not. It's all over 2. The only thing in the of for the natural log here is the 5. If you'd like to use some parentheses around the 5, you can. They're not necessary, but that helps some people. And then it's all being divided by 2, which is not in the of. Okay. Here's another one for solving. Can you subtract 2 and get it into the of? No. Okay, this of has to stay the way it is. So how are we going to get this log and the base 2 to go away? When your x is stuck in a log, you switch to exponent form. So I'm going to take 2 to the power of 2 equals, wow, that whole of x squared minus 2x minus 31. How do you solve a quadratic? You're going to move everything over, make a 0, put it in descending order, and then, of course, we're going to factor. So we have x and x. 35 is probably 7 and 5. One of them needs a negative. Minus 7 plus 5, you say? I think that's going to make a negative 2x. That's good. Okay, so my answers are x equals 7 and x equals negative 5. Now we have to make sure we check these answers. If you take the number, whenever you plug it in, you cannot take the log of 0 or of a negative. So let's check 7 first. 7 squared is 49. Minus, I think that's going to work, negative 5 squared, 25. 25 plus 10 is 35. Oh, even the negative one's working. Okay, both of our answers are good. You have to take the answers that you get and plug it in to the original problem. And you have to make sure that the of is not negative. All right, let's keep going. Here I have a solving one, and x is in that power right there of the log. So I think I'm going to have to do a log circle. 5 to the power of negative 2 equals 25 to the x. Okay, we're going to solve this by making common bases. So let's rewrite 25 with different, let's write them as a base of 5 and an exponent of 2. Okay, still got a little bit more work to do here. A power to a power is very powerful, so let's go ahead and multiply. 2 times x is 2x. Now we have common bases. If bases are equal, then the exponents are equal. Negative 2 on the left equals 2x on the right. I got x equals negative 1. Is that going to be okay? If I take negative 1 and I put it as a power, that makes my of 1 over 25, which is okay. It's a positive. All right, let's keep going here. I'm trying to solve for x. You always try to do as much baby algebra as you can. I can divide both sides by 3. Okay, so if you can do algebra, baby algebra, you do that. We're not going to switch to a log circle till we get stuck. E to the power of x plus 2 equals 7/3. Okay, I'm still trying to solve for x. Can I subtract 2? No. Is there any more baby algebra? I think we're finally stuck. So here, we're going to switch to log. Let's use a natural log. Write down natural log and write down the equal sign. I know the base is e to the power of, let's put x plus 2 over here, and then that equals 7/3. If you'd like to use some parentheses to show that that's all on the of, that would be great. Let's just make sure with a log circle that we set this up the right way, and that is good. We still have to solve for x, so we're going to have to subtract 2. So x is equal to the natural log of 7/3. Okay, it's really nice that we have parentheses there. That's the of. And then when we subtract 2, does 2 get inside the of? No, it just stays after like that. Okay, whenever you're doing your logs, there's a couple of rules you have to make sure that you follow. Okay, remember, we cannot take logs of negatives, okay, or 0. So you should always check. Check to make sure your answer is not an extraneous solution. Okay, by plugging it into the original equation. Use your log rules to help you simplify. If the variable is stuck in exponent, change it to log form. If you're stuck in log form, change it to exponent form. Okay, and how do you do that? You use the log circle, which I hope you got really good at yesterday. Okay, let's go ahead and officially learn some of our log rules. You might remember some of these from your past. Okay, it's not important that you remember the number of them, just that you know how to use them. Okay, so what we'll do here is maybe try to figure these out. If I do a log circle, a to some sort of power equals 1. Do you know what power would turn anything into a 1? Yes, a 0. So whenever you have log any base, if you have log of 1, it makes a 0. Okay, here's another easy one. A, let's see if we can figure it out, to some power equals a. And what's the power got to be? Yeah, it's got to be a 1. So if you have a base the same as the of, then it makes the 1. Okay, let's go ahead and write that down. If your of is the same as your base, okay, if the of is the same as the base, that's what this rule is saying right there. All right, rule number 3. A to some sort of power equals a to the r power. So what's the power got to be? It's got to be an r, right? So again, this rule is also saying if your of is the same as your base, then you just get the exponent. It's kind of the same rule here because the of is the same as the base and then the power was just a 1. So rules 2 and 3 are very similar. Rule number 4 is a little different. I have base a to the power of log base a. Okay, so I notice here that the bases are the same. If your base is a and your base is a, then let's take a guess. What do you think the answer is going to be? The only thing that's left is going to be an m. It's whatever is in the of in the exponent. Okay, that's a to the power of log. All right, let's see if you can apply some of these. So this one right here, I'm noticing 2 to the power of log base 2. So that log is in the exponent, and so I see a 2, and I see a 2, so the answer is pi. Okay, so what we did is we used rule number 4. Now, you don't have to remember the number, but if you're studying your notes, you know how did you do that. I'm referencing that rule right there. All right, I've got log base 0.2 of 0.2, and then there's an exponent. So I'm noticing that the of is the same as the base, so I need you to look at rule number 3, and the answer is negative radical 2. All right, this one is a little tricky. What's the base? That's the of. That's e to the kt power. The base is invisible, and maybe I'll just draw it in there for you to see. So the base is e, and the of is e, so the answer is going to be kt. This is also applying rule number 3. Okay. All right, here come some interesting ones. These really come in handy when you're solving. Okay, so we've got log base a of m times n. So what you can do is separate these into 2 logs. Okay, log and a log. And what do you think the bases have to be? Same as the problem. So they're both going to have base a. So first I do log base a of m plus log base a of n. Okay, and so what is this rule saying here? Okay, when the ofs are being multiplied, you can go ahead and separate them into 2 logs. Okay, this is very similar here. This rule is when the ofs are being divided. When the ofs are being divided, you could also separate them into 2 separate logs. It's going to be log base a and another log base a. And which one's going to go first? The one on top. That's going to be m, and it can't be plus, so this time it's going to be minus log base a of n. Okay, so let's go ahead and solve using these rules. Take a look at this first problem right here. I've got log plus log equal 2. You cannot do a log circle with 2 logs. Okay, so what I really want to do is combine these. Can you combine a log base 4 with a log base 4? Absolutely. It's going to make a log base 4. And what should I do to the ofs? 2 ofs that are being added, you're going to multiply the ofs. So this is going to be x times x plus 6. Okay, so 2 logs can combine into 1 log. Let's go ahead and multiply that out. Log base 4, make sure you use parentheses here, of x squared plus 6x. Okay, now we still have to do some solving. So how are you going to solve? Change it to exponent form. 4 squared is 16 equals x squared plus 6x. How do you solve a quadratic? We're going to have to move everything over, put it in descending order, and of course, factor. So we've got x plus 8 times x minus 2. So we've got 2 answers. X equals negative 8 and x equals 2. But remember, we have to check. Okay, and I'm going to use a red pen for this. Where do you check? You check the answer original, negative 8. I'm going to plug negative 8 in right here. Is it okay for negative 8 to go on this of? Okay, absolutely not. That one's going to have to get crossed out gently, and that one's called extraneous. How about 2? Can 2 go right in there? Log of a positive 2. That's fine. And can 2 go right there? Yes. Okay, so we end up with one solution for this. You check on the original problem for all the ofs, not the of that you created down here, but the original problem. All right, let's try another one here. Can you take 2 logs and combine it into 1 log? And the answer is yes. 2 logs that are natural combine into 1 natural log. And what do you do to the ofs? When it's being subtracted, we're going to divide them. X divided by 4. Okay, let's go ahead and solve this. The base is invisible e to the power of 1 equals x over 4. X is still null. Let's divide or multiply both sides by 4. X equals 4e. 4e, that's going to be a positive. Can I do natural log of positive? Absolutely. Okay, we got 2 more log rules here. The first one is log base a of m to the r power. And this is the one people say they remember the most. They remember this one from Algebra 2 for some reason. That little power m. Do you remember where it goes? It's going to slide right down in front there. R times log base a of m. Okay, so what does this rule actually say? Powers on the of become coefficients. Powers on the m, on the of right there. And this next rule, this is the most fun. If I have a log on the left and a log on the right, the base is a and the base is a. And if the left equals the right, then m equals n. Okay, and so if bases are equal, then the ofs are equal. It's kind of like making common bases, right? All right, let's solve with some log rules. I'm going to solve this problem right here by bringing the 2 downstairs. 2 times log base 5 of x. Okay, let's do some more baby algebra. I'm trying to solve for x, but first, let's divide both sides by 2. Log base 5 of x equals 2. Now I think it might be time for a log circle. 5 to the power of 2 equals x. X is 25. Is that going to be okay? 25 squared? Yep, that's going to be an okay answer. Always check your answers with logs. Here's an example. I've got a base e and I've got a base e. Okay, and there's just 2 of them. There's one on the left and there's one on the right. That's a base e on the left, a base e on the right. So this is an example of rule number 8, where the of on the left can equal the of on the right. We'll just go ahead and solve this. X is equal to negative 8. And is that going to be okay? Negative 8 right here. Negative 8 minus 3. Oh, that's not going to work. Okay, so we're just going to cross this one out and call it an extraneous solution. So what is the answer then? There's no answers left. So then you have to make sure you say the answer is no solution. I tried to get some answers, but none of them work. Okay, we're going to do a couple of examples here on this next page. So looking at this first example here, it looks like we're going to have to do a log circle to get to that x. So let's go ahead and start with the base of 2 to the power of 3 equals 2x plus 1. And then we'll go ahead and solve this equation. So we have 8 equals 2x plus 1. And I'll subtract 1, 7 equals 2x. X is equal to 7 halves. Is that going to be okay? Let's just go ahead and check. 2 times 7/2 is going to be positive. Yep, that's going to work. Another one that I want to do, let's go take a look at number 4 down here. If you have a log and a number, it's not like I can say the ofs are equal because there's 3 things. And it's not like I can move one of the logs to the other side because then there's a 5. So when you have 3 things, you're going to have to combine the logs, except there's this 3 in the way. So this 3 is going to go and be a power on this of. So now we have log base 2 of the quantity cubed, and I've got another log base 2 of 4. All right, so now I've got a log plus a log. Can 2 logs be combined? Absolutely, into 1 log with a base 2. And what do you do to the ofs? When the logs are being added, then you go ahead and multiply the ofs. If you want to write it like that, or maybe some big brackets, so it's clearly all in the ofs, that'd be a good idea. And then we're going to go ahead and do a log circle here. 2 to the power of 5 is 32. I think I'm going to write this as 4. Put the 4 in front. And now we're just going to do baby algebra. Let's divide both sides by 4. We're trying to solve here. I'm going to go ahead and cubed root both sides. How do you undo a cube? Cubed root the left, cube root the right. Do cubed roots make plus or minus? No, they just make what it is. So this is going to make a 2 equals x minus 1, and x equals a 3. Let's go ahead and make sure that that's going to work. If I put a 3 right here, can the so if you have logs with a constant, so there's 3 terms, then this is going to be the approach that you take. If you have something like this up here, where you have 1 log and a number, a log and a number, then this is going to be the approach that you take. Let's say 3 terms with 2 logs. What if we have 2 terms like this one here? There's 2 terms, but there's 2 logs. Okay, so 2 terms, but there's 2 logs. So this one's even better. I love this one. There's a log on the left and there's a log on the right. The base 5 is on the left and base 5 on the right. So this is one of those examples where you could say the of on the left equals the of on the right. 2x is equal to 0. Can x equal 0? I cannot take log of a 0, but if 0 goes right here, the of is a 3, and that's okay. All right, I want you to take a look at numbers 2 and 5 and 6, and I want you to give those a good try, and we'll check our answers tomorrow. Okay, good luck.